So in case of looping functions, how we categorize the loop first, that is the first thing in order to calculate the complexity based on the running time of an algorithm. First we can have linear loops, then we can have logarithmic loops. Then we have linear, logarithmic, dependent, quadratic and quadrated. These are basically categories of nested loops, like in matrix multiplication. And we can have simple and logarithmic loops. So how we can represent or how we understand that what is a simple loop, linear loop or logarithmic loop, we'll discuss that with the help of some examples now. So first example is of simple loops, and under that we'll discuss the linear loop. So what can be a linear loop? So in a linear loop, the number of iterations are directly proportional to the loop factor. So the thing comes in mind is, what is loop factor? Loop factor is basically the number of iterations that the variable, looping variable or iteration variable is going to perform, or the maximum limit, like the size n. So as in this case, the loop factor will be 1000 times, because it will go up to 1000 times. And there can be some code also here, and based on that we are performing this operation, I plus 1. Higher the factor, higher is the number of loops. So जितना बड़ा ये फैक्टर होगा लूपिंग का या लूप फैक्टर होगा, उतनी हमारी iterations होंगी. ठीक है? So based on that we have to calculate the complexity. So complexity of the loop is proportional to the number of iterations. So maximum iteration will be based on this 1000, and 1000 is basically the value of this variable n. So our function which we can derive, generic function that we can derive, is fn equal to n, because n is total number of computation that can be performed. Even if this is one n, this is another n, so total will be 2n, but 2n also is equivalent to your n in terms of complexity, because we generally ignore the coefficients in case we are referring to the complexity. When we talk about complexity, 2n is equivalent to your n, because it doesn't matter if this 2 is attached with this n. So 2n is almost equivalent to your n. So if we talk about the total number of operations, that will be 2n, but if you talk about the complexity, it is in order of n, in order of the input size. That's why we always refer to the input size to assess the complexity in terms of the factor of n. तो generally जो हमारा ये function बनता है, ये n की terms में बनता है. n is basically the size of that input. Then we have next again linear loops, but here the increment is of 2 steps. Like earlier we have I is equal to I plus 1, here we have I is equal to I plus 2, and this loop factor remains the same. But based on this condition, the loop factor will reduce to 1000 divided by 2, that is 500 times. That means every time the I is incremented by 2, so it will not perform 1000 iterations, it will perform only 500 divided by 2, that is 500 times it will be executing. So the complexity can be like n by 2. Okay? So in both the cases of linear loops, if we plot the graphs, so it will be a straight line graph. Okay? Whether it is n or n by 2, it will be a straight line graph. We'll discuss that later on maybe. Then we have second category of logarithmic loops. Now we consider a loop in which we perform the multiplication and division operation. How we can say that? So the same loop in which the loop factor is 1000. Here also it is 1000. It is initialized to 1000 here first, and we are executing this loop in the reverse order. Here we are executing in the normal order, starting from 1. This is the initialization statement. So I is starting from 1 and going up to less than 1000. And here I is starting from 1000 and going up to less than equal to 1. So this is going in the forward direction starting from 1 to 1000, and this is going in the reverse direction starting from 1000 to 1 or maybe 0. So same thing, earlier we are performing I is equal to I plus 1 or I plus 2. Here we are performing I is equal to I multiplied by 2 or I divided by 2. Wherever you are performing some multiplication or division operation, so that will be termed as a logarithmic loop, in which there will be logarithmic number of steps to perform that operation. So we'll discuss that logarithmic. So in case of multiplication, the value is 1, value of I is 1. then it will be 2, then it will be 4, then it will be 8, then it will be 16, 32, and so on. So as you can see, it is not incrementing at a constant pace. Earlier we are incrementing, like initially value of I is 1, then 2, then 3, then 4, but now we are incrementing in some logarithmic terms. So that is the meaning of log. So this is all logarithmic terms. Here, similar is the case here, like we are initially incrementing by 1000. The increment factor is not constant. So it is like 1000, then 500, then again division 250, then 125, so on, so on, so on. 125 divided by 2 is like 62.5, so we have taken the 62 value only. Similar is the case in the next statements, like 31 divided by 2 is 15.5, so we have taken the whole number 15, ignored the decimal part. Similar is the case in elsewhere. So if we consider both the iterations, if we talk about iterations only, it will be 10. So 10 is the total number of iterations. So that means for each iteration, the value of I is double for multiply loops, and value of I is reduced to half for the divide loop. Initially the value of I is 1000. So next iteration में 500 हो गई. That means 1000 divided by 500. So that is half हो गई वो. और I multiply loops के केस में I double हो रहा है. I 1 है, फिर 2 है, फिर 4 है, फिर 8 है, then 16, then 32, 64. So based on this, although we are performing it in a different way, but iterations remains the same, that is 10 in both the cases. Because the input size is same, but we are performing logarithmic calculations. So how it is logarithmic? Like the loop continues while the below conditions are true. Like 2 raised to power iterations is less than 100. Number of iteration, like first iteration, second iteration, third iteration, or 0th iteration even. So based on that, we are performing operation, and here in case of divide, we are performing operation up to this condition. So therefore, the iterations in the loops that multiply or divide are determined by this formula, log n to the base 2, because we are expanding in the logarithmic section. If you know a bit about mathematics, so this multiplication and division is corresponding to the logarithmic expansion of that particular algorithm. So it is taken as base 2 by default, and n is the size of the input, that is basically 1000. Then we have nested loop. So iterations are basically outer loop iterations and inner loop iterations in this case. And if you take the algorithm, so like I is equal to or less than equal to 10 and starting with 1, whereas j is also starting with 1 and less than equal to 10. So this is like a nested loop. Here we have application code, and j is incremented by 2 or multiplied by 2, and I is incremented by 1. So if we take the outer loop and consider this outer loop and its iterations, so iterations will be dependent upon this n, which is here right now as 10. So if we take specifically this algorithm into account, so the outer loop will give us 10 iterations because I is incremented by 1. But for each iteration of I, how much time j is going to be executed? 10. But see this, now j is incremented by or multiplied by 2 once again. So it is similar to the previous multiplication factor, like where the multiplier is performing this operation. So where the multiplication is the factor to increment this particular thing, so we always have the logarithmic loops number of iterations. And here the linear loops is followed. So based on the size, as size is 10, so 10 log 10 base 2, because n is 10 in case of j also. j के केस में भी 10 है n की वैल्यू, i के केस में भी 10 है. अगर जेनरिक बनाना चाहते हो, so it will be like n log n, like this is a generic function for this particular algorithm. और specific की बात करेंगे तो we'll have 10 iteration for I loop and 10 iterations for j loop, and so 10 multiplied by 10, because j will be executing for each and every iteration of I. That's why here we have multiplication symbol. हर आई की आइटरेशन के लिए j 10 बार एग्जीक्यूट करेगा. I की वैल्यू 1 है तो j 10 बार एग्जीक्यूट करेगा, बट नॉट 10 टाइम्स, बट बेस्ड ऑन दिस लॉग फैक्टर, बिकॉज 10 तक जाएगा बट ये इस लॉग फैक्टर पे डिपेंड करेगा. log 10 to the base 2. So generalized factor can be log n to the base 2, because अगर यहाँ 10 की जगह n होता और यहाँ m होता, so वो m log n हो जाता. if this 10 is like m and this 10 is like n, so it will be, complexity will be like m log n base 2, and base of this log will be 2. This is how the things will work in case of we have this kind of structure. Then we have dependent quadratic. What is the meaning of that? As we can see, the same algorithm is being followed. Here the size is 1000 for this I. J is incrementing or initialized again by 1, but J is dependent upon C, the factor I. So J is dependent upon I. Based on the value of I, the J will increment or J loop will be performed. So this is example of quadratic. So in case of this outer loop, as it is incrementing by 1, so it is like a linear loop. So Fn can be, function of complexity can be based on this n or the number of inputs. Next, in case of inner loop body, initially the value of I is 1, J is 1. So based on the condition which we can see here, J less than equal to I. As per this condition, when I and J are equal, like 1 and 1, so this J plus 1 will execute only once. When value of I is 2, so J is again initialized with 1, and it will go starting from 1 less than equal to 2. So it will execute once, then it will again check the condition, execute once again, and then at the last it will move out. So first time it will execute once, then twice, then third, and based on the number of inputs it will go up to 10. So if the value of I is 10 or 1000, so it will go up to 10 or 1000. Depends upon whatever input you provide. We are just considering for first 10, but it will go in the same way for the 1000 also. So if we analyze the first 10, it will be like average we are calculating. So based on this, if we calculate this, if we represent this thing mathematically, so it will come out like this, n plus 1 by 2. This is how the mathematical representation of this value can be retrieved. So as we have to calculate the function, which is outer loop multiplied by inner loop, so it will be outer loop complexity multiplied by n plus 1. That is the total number of iterations. So generic function for this will be like this thing. So n into n plus 1 by 2, that is the total number of iterations. Then we have quadratic loop. Again, I starting with 1 to 10, J starting with 1 to 10, and J and I both are incrementing by 1, so both will be treated as linear loops starting from 1 and going up to the value 10, or you can say this 10 can be generically represented as n, and both can be represented as n. So it is for linear loops, it will be like n for inner as well as for outer, so it will be like n multiplied by 2, so function will be like n square. This is how we can calculate the different quadratic as well as looping based complexity. So if we talk at an algorithm in which there is no loop or iteration, so number of instructions are executed once or a few times, so the total time requirement is a constant requirement, like there will be a constant time. So for constant time we can say that running time is constant function of something, so it will be treated as 1. Constant running time is represented as 1. If you have a big problem which is solving, like having a logarithmic behavior, now we know what is a logarithmic behavior, so it will be log n, where we have linear computations like in a loop, normal loop, incrementing by 1. There is no dependent factor, so there is small amount of processing done on each element, then it will be a linear running time. In case we have a combination of things like something is linear and something is logarithmic, so we can have n log n. So like problem is solved by dividing into smaller problems, solving them independently and combining the solution. So that can be the example, like this is independent and this is like solving them separately and combining the two parts. So it will be n log n. Then next is quadratic, where all pairs of data items are process for double nested loops, so it will be like n square. For triple loops, it can be like n cube, and for exponential algorithms for generally practical uses, it can have 2 raised to power n also. We'll discuss that how it comes also. So that is all for the today's session. Thank you.